Hello students, in this session we will discuss about kernel map for simplification, which is a very important application for the Boolean algebra. So before going to the Boolean application part, we should discuss about the Boolean function. So what do we mean by Boolean function? Let's take an example, and with this we will discuss about this. So let x1 x2 equal to x1 dash meet x2 be a Boolean expression where x1 and x2 can be take the values of 0, 1. We can calculate the values in this expression for different pair of values of x1 and x2 using the Boolean algebra. And let's take this the table. Here x1 x2, we know Boolean algebra always consists of the values 0 and 1. So let's, for x1 this 4 values and for x2 this 4 values. So for this x1 we have taken the x1 dash, that is 0 1 0 1 1 0 1 0. Now the meet of the x1 dash and x2, x1 dash and x2, this is the 0, this is the 1, and this is the table. This is called the truth table. So whenever we are inputting these two values, we have got these values. So this gives the Boolean function for this expression this, which may be denoted by f such that b square tends to b. Such function is called Boolean function. So another definition for the Boolean function is, let this be a Boolean algebra and a function f such that bn to b, defined as f consists of an to a1 to an, which is equal to e, the Boolean values, that is a1 to an, where a1 a2 an belongs to bn, for all ai belongs to b. This is called a Boolean function if it can be specified by Boolean expression of n variable. Okay, there is a note, every function g such that bn to b is not a function, not a Boolean function. Okay, every function bn to b is not a Boolean function. However, as Boolean function only consider the values 0 and 1, so for the case of two-valued Boolean algebra 0 1, any function from this to 0 1 is a Boolean function. This is a special case. So now let's do for the kernel maps. So what do you mean by the kernel maps? This map is a graphical technique to simplifying a Boolean expression in the minimal sum of products or the minimal products of the sums. So why we will go for the simplification? Our main role, our main issue, हम जिसके लिए काम करना चाहते हैं वो ये है कि हमें सबसे पहला मिनिमम नंबर ऑफ सम ऑफ टर्म्स चाहिए, और दूसरी बात ये है कि हमारा जो नंबर ऑफ लिटरल्स है वहाँ पर भी मिनिमम नंबर ऑफ होना चाहिए. सो goal of the simplification is there are a minimal number of products or some terms, and each term has a minimal number of literals. Now this is the truth table for the kernel map. So let's say take two variable function has 4 possible minterms. We can rearrange this minterms into a kernel maps. Let's take x this part and y is this part. So this is the minterms. We know what is minterms. So this can be written as this 0 1, x is the 0 1, this is the x part, this is the 1x part, this is y 0 1. So we know the complement of 0 is 1 and 1 is 0. Here we can take like this. So from this we can write like this, and from this we can also write this. These are interrelated. From this x we can take common. So y x plus y, that is 1. So this is x part, this part is x. Here we can take common x. So this part is x part, this is x part, this is x part, this is y x, this is y. So this total line is x, this is x, this is y x, and this is y. These are written here like this. So let's take two variable sum of minterms. Here let's just imagine this minterms. Here using the truth table, or simply we can take x common, that is y x plus y. Y x plus y equal to 1. So this is a x. Okay, this is the main function our this was just last as it is. This is the first upper term. So here let's take this as a rectangle. Here we can take common x dex. This is the y dex plus y. So this is from the distributive law, we can take this as this, and x dex dot 1, that is x dex. So for the another example, let's take the example of the expression x dex y plus xy. So here both the right side we can take common as y, and x dex plus x, again this is equal to 1 into y, so this is y. So we can reduce this to just y. So this is the part. What about this x dex y dex plus x dex y plus xy? So this is the first, this part here we have taken, and for the second part, for this we have got the x dex, and for this part here we can take y as common. So from this we can, this is the corresponding to y. So the whole expression of this can be written as this x dex plus y. So we can now, this can overlap here. So this is the x dex plus y part. Now for the 3 variable kernel map, let's 3 elements, 3 inputs x, y and z. Then the arrangement can be made a tricky arrangement. So here let's, this is the 0 1, that's the x dex and x part. This is the 0 0 0 1 1 1 1 0. So this is the yz part, this is the x part. So we can also written like this, whatever this value can be equivalent to m0, this is m1, m2, m3 and m2. This is m4, m5, m7 and m6. This can also be written as like this. Here in the middle of this, this is the y dex part, this is the y, this both are y dex and these are the y. So we can also write like this. Here this is the x part, this is the z part and this is the y part. Little bit difference is there, but whatever, they are equivalent to each other. So what a funny ordering, let's see about this. With this ordering, any group of 2, 4 or 8 adjacent squares on the map contain common literals that can be factored out. Means here if there is a 2 cross 8 rectangle, 2 cross 8, अगर यहाँ पर अगर 8 रेक्टेंगल्स हैं तो हमें क्या करना है, जो भी ट्रूप लेंगे यहाँ पर हम 2, 4, 8, 16 इसी तरह से हम लोग एडजेसेंट स्क्वायर लेंगे. 2 to the power n square हमको लेना है. So here for this red dotted line, this x dex, y dex, z and x dex, y, z. As we are taking here the common, so union, so x dex, y dex, z plus x dex, y, z. So here what is the common part? This is x dex, z part is common. So y dex plus y, the value of this is 1. So x dex z plus into 1 is x dex z. So the value of this is this expression are equivalent expression. Again we can adjacently include wrapping around the left and right sides. What does it mean? So if we are taking this both side for the union, here we can for this total we can take z bar common. So now this part is this. Again in this section here we can take common as y bar and here y. So y bar into x bar plus x plus y into x bar plus x. So here this equal to 1 and this equal to 1. So z dex is into y dex plus y. Again y dex plus y equal to 1. So this is equivalent to z dex and we got this value as z. So this total is equivalent to z. Hence these are adjacent parts. So using this property we can do many more simplification. Now for the truth table, we can if x, y, z 3 elements are there and let this is the function. So for this 0, 1, if we will write like this 0, this 1, this and this. So we know this are from the above next slide, before slide we have taken this. So using this we can calculate like this, that this is the we can find the minimal of sum of products expressions. Each rectangle corresponds to one product term. each rectangle correspond to 1. Here we will consider only one term and we don't bother about the 0 term. We have to focus only the 1 and the minimum number of literal also. So for this, 1 is this is this. So before taking this side, these are values. So using the values from our before slides, these are the values. So we can write like this. This is this and this. So here in this section we can take common as y-dex and z. So x-dex plus x, that is 1. So this total column is y-dex z, and here this row we can take common xy. So z plus zs, that is 1. So this is the xy column. So our function is y-dex z plus xy. Now grouping, how we will group in the mean terms. Okay, the most difficult step in grouping together all one in the K-map. Our main difficulties part here is to group all the one in the rectangle. So make rectangle around groups of 1, 2, 4 और 8, 1s. So हमें यहाँ क्या करना है, हमें जो रेक्टेंगल बनाना है वहाँ पर 1 रहना चाहिए. 1 किसका 1 बने, 1, 2, 4, 8, 1, 2, 4, 6 इसी हिसाब से एलिमेंट रहेंगे, लेकिन चारों सब में 1 रहना ज़रूरी है और उसी हिसाब से हमको रेक्टेंगल बनाना है. और सबसे बड़ा जितना बड़ा बना सकते हैं उतना बड़ा रेक्टेंगल हमको बनाना है, बट 0 को हम लोग इग्नोर करना है. सो ईच ग्रुप कॉरेस्पॉन्ड टू 1 प्रोडक्ट टर्म्स, ताकि हम सबको मल्टीप्लाई कर सकें. सो यहाँ पर क्या है, 0, 0, 1, 1, यूज दिस. सो हियर दिस इज 1, 1. So this is a rectangle, this is also a rectangle. We can take these 3, 1, 2, 4, 8. In this order we have to take. So our main simplest result is make as few rectangles as possible to minimize the number of products in the final expression. Again, make each rectangle as large as possible, as few as possible and as large as possible. We have to make सबसे बड़ा लेना है और जितना कम हो सके लेना है. जितना कम लेंगे उतना अच्छा है, जितना बड़ा ले सके उतना अच्छा है. बट वन कंडीशन देयर, रेक्टेंगल कैन बी ओवरलैप्ड. इसमें हमारा कोई बस नहीं है, रेक्टेंगल तो बड़ा लेंगे लेकिन उसके अंदर ये ओवरलैप भी हो सकता है. सो लेट्स टेक दिस एग्जाम्पल. ओके, लेट्स कंसिडर द सिंप्लीफाइंग द फंक्शन xy plus y-z plus xz. Okay, we should convert the expression into a sum of the min terms form. This is easiest to take truth table for the function and then read the min terms. ये truth table लेकर करना जितना आसान है उससे कहीं ज़्यादा हम लोग को easy लगेगा ये कलर मैप से, क्योंकि हम अब इसे पढ़ना सीख गए हैं. So here कोई मैथमेटिशियन इसको पुराने इसको बैक जाकर करते हैं, जहाँ पर आपको क्या करना है, अपने मन में आप लोग को ये z-x plus z इसी टाइप का लेना पड़ता है, और कोई इसको इजीली बना सकता है बाय कलर मैप की तरीके से. तो फर्स्ट अप्लाई द डिस्ट्रीब्यूटिव लॉ इन रिवर्स टू ऐड इन मिनिमाइज इन मिसिंग वेरिएबल्स. मतलब यहाँ पर जो मिसिंग वेरिएबल है वो हमको ऐड करना है विद द 1. एंड वेरी फ्यू पीपल एक्चुअली डू दिस, बट इट इज़ ओकेजनली यूजफुल. ये बहुत कम ही लोग यूज़ करते हैं लेकिन ये यूजफुल है. सो फर्स्ट आवर टास्क इज टू मेक द मिसिंग टर्म इनटू 1. So here xy, here we have a z that is missed here, so we can take in place of that missing z as 1. So xy dot 1. For this y-dex z plus into 1 and this xz into 1. Now for z, here z is missed, so z-dex plus z. Here x is missed, so x-dex plus x. Here y is missed, so y-dex plus y. Now using the multiplication, that is distributive. Okay, x y z x plus x y z, x dx y dx z plus x y dx z plus x y dx z plus x y z. So using all these terms, x y z is there, this is x y z and here this is x y z. So we can take any one of them. This is x dx y dx z, this one, and this is x y dx z. These are the two, so we can take any one of that. So this is our function, this is our expression. So using simplification rule we can do here. Now how to make a K-map? So let's take the function fxyz in equivalent ways this. Either you can write like this or in m forms. So if we are taking this is the table, for this is the table. So let's take this for the simplification, and for this x dx y dx z, x dx y dx z, x dx y z, x dx y z x, and these are the so our first work is to make rectangle as big it is and as minimum it is. तो हमें क्या करना है, जितना बड़ा हो सके उतना बड़ा रेक्टेंगल लेंगे और जितना कम हो सके उतना कम रेक्टेंगल लेंगे. सो यहाँ पर क्या है, हमारा ये दो लाइन में 1 आता है और यहाँ पर हमारा यहाँ पर हम 2 को ले सकते हैं. यहाँ पर 2 के लिए हम एक रेक्टेंगल बनाएंगे और यहाँ 2 के लिए हम रेक्टेंगल बनाते हैं. सो यू कैन डू फॉर योर योरसेल्फ एंड लेट्स हियर सॉल्यूशन फॉर द स्टेप 1. हियर this is our question. So for the solution of this is here, ये जो हम बनाए हैं for this, here this is the x bar or x dex, this is the y dex, this is the y. So for this is x dex, this is the z. So x dex z this is, and this part is x, y and z, and this is y dex and z. So you can do this for yourself, and our summary is K-map are an alternative to algebra for simplifying the expressions. Here the result is a multiplication of a minimum of sum of products and minimum of product of sums, which leads to a minimal 2-level circuit. It is easy to handle and don't care conditions. Here K-maps are only good for manual simplification for all the expression. Things here you have to take in your mind that remember the correct order of min terms and max terms on the K-map. When you are grouping, you can wrap around all sides of the K-map on your groups, can overlap and make as few rectangles as possible and make as large rectangle as possible, and this leads to simpler and product terms. So do practice and practice solve so that you can solve all the problems. Thank you.